Hi guys, so this next lesson is about rectangles. So rectangles are a type of parallelogram. So it has all the same properties of a parallelogram, the ones that we learned last time, but there are two more that we're going to add on that are only true about rectangles. Okay, so these notes are linked on Classroom in case you want to print them and fill them out. Otherwise, you can just write them on a sheet of paper or just follow along on here. All right, here we go. So that's the first thing about a rectangle is that all four corners are right angles. So if I gave you this rectangle, we could mark that all four angles were right angles. So they're all equal to 90. That's probably something you already knew about a rectangle. Okay, something else about a rectangle, Theorem 6-9 is, this reads, if a parallelogram is a rectangle, then its diagonals are congruent. So that means they're the same length. They also still do bisect each other, like in a parallelogram. So if you want to draw a little picture over here, I'll draw in the diagonals. So these diagonals would be the same length, and because they cut each other in half, all four of these little pieces are equal. So let me just move this over for a second. So if I said this was rectangle REC, okay, so if this was rectangle RECT, the diagonals are RC and ET, and they're equal. So if I said RC was 10, ET would be 10, and all the little pieces would be 5. So that's the second property of a rectangle that's different from just a normal parallelogram. Okay, so in this picture, we're just going to label everything that's true about a rectangle. That way you can reference it when you're doing practice. So, when you're doing practice, something will be labeled on the rectangle, and then you can refer back to this to help you figure out what's true about what's labeled. So first, we know that opposite sides are equal. So let's mark the opposite sides equal. Let me zoom in on just this. Okay, then we learned that it has 4 right angles. So in all 4 corners, we can label those as right angles. Okay. We also just learned that the diagonals are congruent and they bisect each other. So that would make all 4 of these little pieces equal. So I'm going to put 3 tick marks on those. Okay, the last thing that's kind of cool about a rectangle is there's some stuff about the angles that I think is pretty cool. And so this angle up here, notice that it's alternate interior with this one down here. If you guys remember alternate interior angles, it's when they're 2 angles on different sides of the transversal, both on the inside of parallel lines, because I forgot to mention too, since this is a parallelogram, the opposite sides are also parallel. So things like alternate interior angles would be true. One other cool thing is that these, let me highlight this for a second. These triangles, this one here, and this one here, are isosceles triangles. So I don't know if you guys remember what that means, but remember isosceles triangles, the base angles are the same. Base angles are the same. So what that means, let me erase some of this, is not only are those alternate interior angles congruent, but they're the same, they're the same as these two as well. So all 4 of those angles are the same. One other thing about a rectangle, since these corner angles are 90 degrees, these two angles would add to 90. Okay, so this angle here, color haven't I used? How about some pink? This angle here rather, is going to be equal to this angle here, because they're both going to add to the green angle to make 90. And then they're also the same as these because we have two other isosceles triangles. Okay, so that's everything that's true about a rectangle that you may need to complete the practice. So we're going to do just a few examples, I think just 3 examples that are similar to the ones that you're going to do on your practice. So it says quadrilateral ABCD is a rectangle. Find the value of x and any other missing values. So the first thing you want to do is label the picture. Notice it says AC is 4x minus 60. So that's this whole thing. And then BD is this whole thing. So these are the diagonals of the rectangle, which we just learned the diagonals are congruent. So because the diagonals are congruent, we're going to set them equal to each other. Okay, so we're going to have 4x minus 60 equals 30 minus x, because the diagonals are equal. So that's your equation, and then we're just going to solve for x. So we need to get the x's on the same side, so I'm going to bring this negative x over to the left by adding. So we have 5x minus 60 equals 30. Then we will add 60 to both sides. So we have 5x equals 90. And then our very last step would be to divide by 5. So x equals 18. Okay. This question was actually also asking us to find AC. So all you would have to do, AC, remember, is this diagonal. So we would just have to plug it in. So AC is 4x minus 60. So you're just going to plug in 4 times 18 and then subtract 60. So 4 times 18 is 72. Yes, 72. 72 minus 60 is 12. So that means AC is 12. So this is 12 and this is 12, and then all these little pieces would be 6. Okay, so that's the first one. If you're given the diagonals are equal, so you want to set them equal to each other. Okay, here is number 2. So number 2, we are given AR right here and BR right here. So these are the halves of congruent diagonals, which are equal because, again, remember that all 4 of these pieces are equal. So again, we're going to set them equal to each other. So you're going to have 2x plus 3 equals 12 minus x. Again, we want to get the x's on the same side, so I'm going to add x to both sides. So I have 3x plus 3 equals 12. Subtract 3. So 3x equals 9. Divide by 3 to get x is 3. Okay, this question is also asking us to find BD. So to find BD, if we take a look at the picture, BD is this whole thing. So if we can find this part, BR, and then we would just double it to find BD. So let's find BR by plugging in 3. So that's going to be 12. Instead of minus x, I'm going to put 3. So that means BR is 9. So this part's 9, this is 9, this is 9, this is 9. All 4 pieces are 9. So therefore BD would be 18. 9 plus 9. Okay, so there's number 2. Sometimes you're given questions where you have halves of the diagonals and all 4 of those are equal in a rectangle. Okay, this is the last one we're going to do. We're going to skip number 4 because you don't have any examples like that on your practice. So let's do number 3 now. So number 3, we're given BAC. Angle BAC is 4x plus 5. So BAC, that's right here, 4x plus 5. And then the other one we're given is CAD. CAD is 5x minus 14. Okay, so we have to think about what do we know about these angles. So what you could do is you could scroll back to, let's go back to the, whoops, don't want that. Let's go back to this right here. Basically, the angles that I just labeled in the picture are this one and this one. Notice that those are not equal. Probably the most common thing that kids do with a problem like this is they set them equal to each other. Kids just want to set everything equal to each other, which would make things a little bit easier for us, but that's not what the relationship is here. So hopefully we remember that in a rectangle, the corners are 90-degree angles. So this whole corner, these 2 angles together would be 90. So therefore, for our equation, we're going to add them and set it equal to 90. So we're going to have 4x plus 5 plus 5x minus 14 equals 90. Now, when you're solving this one, you have to be careful because all of this is on the same side of the equation. So therefore, to solve, you want to just combine like terms. So let's see, we can combine the 4x and the 5x. That's going to give us 9x. And then we can do the positive 5 and the negative 14. That would be negative 9. Okay, so then we can add 9 to both sides. And then we have 9x equals 99. Lastly, you're going to divide by 9 to get that x is 11. Okay, this problem is also asking us to find the measure of angle BAC and the measure of angle CAD. So we can plug that in. Okay, so for angle BAC rather, we're going to have 4 times 11 plus 5. 4 times 11 is 44, plus 5 is 49. Then for CAD, we have 5 times 11 minus 14. 5 times 11 is 55, minus 14 is 41. Notice that our answers, 49 and 41, add to 90, right? And they should, because that's what we set up. Okay, so that's the last type of example that you'll probably see. There are going to be some too where they might give you like opposite sides, but we've already done ones like that with parallelograms. So just remember, opposite sides are equal. Okay, you may also have an example where, let's just say we give you something for like this angle or like one of the corners. Remember that all the corners are 90, so you would set it equal to 90. Okay, so one last thing I wanted to show you is this chart is something that I added on Classroom. Normally in class I would have passed this out to you and we would have filled it in all along like for each section. So this is just a way to have all of your properties of the quadrilaterals. These are all the ones we're going to learn. It's just a way for you to have it all in one spot. So I'll post this on Classroom to help. So we learned this parallelograms the first day. And now today we learned this. So you would use this to help you, the rectangles. I also drew little pictures on the side so you could like, hopefully that makes sense. Hopefully it explains rather like what the words mean if you need a picture to help you. Okay, so next time I'll probably have you do even more rectangle practice and then eventually we'll learn about squares and rhombi, that's the plural of rhombus, and isosceles trapezoids. Okay, so that's it for today. Please let me know if you have any questions about your practice, and you can join our live help session at 12 o'clock. All right, thanks guys.